I have a packet tracer lab here that is a lab of a small enterprise network, and today I'm going to go over the topology and configuration and how I decided to configure this. So we're going to start with the topology. At the top here, we have an ISP router, and the enterprise has two separate routers, R1 and R2, that connect to this router, and this is for bandwidth and redundancy. So if R1 goes down, traffic will be routed to R2 to send out to the internet and vice versa. Then we go down to the distribution layer. We have two distribution layer switches. These are multi-layer switches that can handle both layer 2 and layer 3 traffic. And in between them, there's a port channel. Again, this is for redundancy and bandwidth. So if router 1 up here goes down, more traffic needs to go over to the right side for distribution switch 2, and the port channel helps control that data flow. And then going on down to the access layer, we have two access layer switches. They both have two interfaces that connect to each, sorry, one interface that connects to each distribution layer switch. So access switch 1 has a trunk interface going from itself to distribution switch 1 and itself to distribution switch 2. And access switch 2 has the same. It has one trunk interface going to distribution switch 1 and one interface going to distribution switch 2. Is again redundancy. If one link goes down, they still have a way to get out to the rest of, to get to the core layer of the network and out to the internet. And then these switches also have access VLAN ports configured on them. On the left side over here with access switch 1, we have the staff VLAN, which is VLAN 10. We have one device in the admin VLAN, which is VLAN 20. Then we move over to access switch 2. We also have another device over here that is in VLAN 20 with the admin network. They have their IT VLAN, VLAN 30, and there's also a management VLAN that currently has a DHCP server, and it has a static IP address of 10.0.99.10. The goal is for all of these devices in each VLAN to be able to get their network information from this DHCP server. I have already configured the DHCP server with all the VLANs. The config's also here in my my mop here, but I went ahead and did that just as a time saver. I've also configured this left portion of the network, so router 1, distribution switch 1, and access switch 1. And we'll go through the configurations for the right side for R2, distribution switch 2, and access switch 2. All right, so let's go ahead and jump into it. So over here on the right, we have the configuration for R2. We start with enable and conf t to get into configuration mode. We change the host name to R2. We set up my username, my privilege, and my password. We enable service password encryption across the entire device, and then enable a secret admin password for good measure. LLDP run is going to turn on LLDP on all interfaces on this device so that neighbors can see what they're connected to. And then here with the VTY, line VTY04 command, this is going to allow us to SSH up to 5 people SSH into the device using a local login password. And then the next one is the console configuration for the console port, again using a local login password, username and password. We have access control list here for NAT purposes, because I did also configure PAT on this router in this network. We're going to start with interface G00. This is R2 to the distribution layer switch 2. And it's got an IP address of 10.0.2.1 with a subnet mask of /30. And it is the inside NAT address. And no shutdown turns the port up so that it can actually operate. Next is the G001 interface. This is going to be the R2 connection to the ISP. And it's got an IP address of 203.0.113.6. And it's also a /30. The R1 is the 203.0.113.0 network, and this is the 203.0.113.4 network to make it work here in Packet Tracer. And this is the IPNet outside address. And then again, no shutdown. I also configured the loopback addresses on each of these devices, and this one is 2.2.2.2/32 and no shutdown. The first IP route, the first static route we have here is the default route. It is pointing to the interface on the ISP router, the 203.0.113.5, so that any IP that needs to go out to the internet will go to the ISP router and then out to the internet. And then I have the IPNAT inside source list 10. This is calling that access list. And I have it labeled here on interface. Let's see, it's on a G00 and then the overload as part of that command as well, so that when things come into the network from that G001 interface, it'll be natted to the IP addresses that are inside the network, and as they go out, it'll get a public IP address. All right, and then we have router OSPF. This is setting up OSPF on this device. Router ID 2.2.2.2, that's that loopback interface. And then these two network commands, 10.0.0.0.0.255.255 area 0. This is basically saying any IP address that is within a 10.0.0.0/16, turn on OSPF on that interface. And it's the same for this one. I just went ahead and ran the 192.168 here as well and gave it the same command. The default information originate command is going to be so that through OSPF, this router will tell other devices that are using OSPF, hey, this is how you get out to the internet, come through me, and I'll send it to the 203.0.113.5 to the ISP router and then out to the internet. Then we move down to the distribution layer switch. This is a DS switch 2. And same kind of configuration up here, the name, my privilege, and my username and stuff, the LDP, the the config for SSH, the console server, and then we have, because this is a switch, we have spanning tree mode rapid PVST. This turns on RSTP to make STP configuration a little faster when things are plugged in, when switches are plugged in. And then it has IP routing. Since this is a multi-layer switch, to enable a layer 3 capabilities, you have to use the IP routing command. All right, and then next we have VLAN 10, 20. This is just naming out all of the different VLANs that are in the network. Go ahead and creating those on the switch. Next, we have the interface port channel. This is the port channel that connects distribution layer switch 2 to distribution layer switch 1. And run the no switch port command so that these interfaces can actually run layer 3 operations and be configured an IP address of 10.0.3.2, 255.255.255. It's a /30 and then no shutdown. Then we move to interface G01. This is the interface that is connected to R2, so to the router. Turn on no switch ports that can be configured with an IP address of 10.0.2.2/30. And then next is interface range. This is interface F01 through F03. So these are going to be those port channel interfaces, switch 2 to switch 1, no switch port, and then channel group 1. This is calling that port channel configuration we did a little earlier, and then making the mode active. And this is also pretty much the same configuration that's on distribution layer switch 1, so that they can send traffic between each other on this port channel. All right, and then we come to our first trunk interface, interface F04. Description is distribution switch 2 to access switch 1. Switch port trunk encapsulation.1q. In order to actually turn this to make this a trunk port, we have to tell it what tagging it needs, and that's the encapsulation.1q. And switch port mode trunk, that actually puts the interface into trunk mode. Switch port trunk native VLAN 999. So I changed the native VLAN from being VLAN 1 to VLAN 999. That's best security practice. And then we have switch port allowed VLANs saying that VLANs 10, 20, 30, and 99 can actually go across this trunk port. And F05 is basically the exact same thing. Again, these are redundant interfaces that connect to each of the switches for redundancy. And then the next thing is the VLAN 10 SVI that I'm creating here. This is giving the VLAN a gateway of 192.168.10.3. And then because I've enabled HSRP in this network so that each VLAN has a preferred distribution switch that it'll go to, and then a secondary in case that switch, that primary switch goes down. So the physical address of a VLAN 10's gateway is 192.168.10.3 for this particular interface here for VLAN 10, but the logical interface is going to be 192.168.10.1. So anytime anything is configured with a gateway of 192.168.10.1, it will go through this 10.3. Well, actually, this is the secondary one. So for VLAN 10, distribution switch 2 is secondary. So it'll go, VLAN 10 will go to the distribution switch 1 first, and if that goes down, that's what it prefers. And if it goes down, it'll go over to distribution switch 2. And it's the same for VLAN 20. VLAN, actually, I just noticed a problem with this configuration that we're going to fix right now. So this needs to be standby 2. Let me fix these real quick. I probably got that wrong up in the other switch as well because I copied and pasted. So we'll probably have to go back and fix that as well. All right. So before I go back and fix the other distribution layer switch here, we're going to look at, where was I? The IT VLAN, VLAN 30. Again, it's this first, it's labeled as 192.168.30.3 physically, but virtually it's 192.168.30.1, and it's going to be the primary distribution switch 2 is going to be the primary distribution switch for VLANs 30 and VLAN 99. And then they all have an IP helper pointing to the DHCP server. So basically, normally, so they'll send a DHCP request to the distribution layer switch to their gateway, and the gateway will go, well, I got to send this over to the DHCP server, get them to give me your information, and then we'll send it to you. And then again, a loopback interface. This one is 4.4.4.4. The distribution switch 1 is 3.3.3.3. Right, and then we've got more OSPF commands over here for 4.4.4.4. Same kind of command as before. Yeah, it's pretty much the same across all the devices that need OSPF so that they can all talk to each other and share routes. All right, now we have the access switch 2. Same configuration, same basic config as before, just set everything up. This one has the spanning tree port fast default command. So basically what that's going to do is going to enable port fast on all ports unless it is configured with a trunk port. So all these access ports that are going to these VLANs, they're basically going to come up immediately without having to run any kind of spanning tree because it'll automatically know that they don't need BPDU sent. So it's just going to be in a forwarding state, except for trunk ports. It won't do that with trunk ports. It'll still go through the same STP process for trunk ports. And again, same VLANs here. I configured all the VLANs on all the switches. And then interface F01, that's going to be the distribution switch 2. It's primary distribution switch. Similar thing here. We don't have to do the encapsulation on the access layer switch. So switch port mode trunk, native VLAN 99, all native VLANs have to be the same across the entire network or you're going to have some problems. And switch port trunk allowed VLANs, same thing. It allows VLANs 10, 20, 30, and 99. And then F02, that's to distribution switch 1, same kind of configuration. That's its secondary switch. And then we have the actual access configuration for the VLANs. So F01 is going to be an access mode interface, and it's going to be access VLAN 20. 4 through 5, so interfaces 4 and 5, F04 and F05, they're going to be the IT department, so they'll be configured with VLAN 30. And then the DHCP server is at F06, and it's going to be configured with VLAN 99. This separates the network into virtual networks, so they're outside of each collision domain. And then here's the DHCP server settings, but we won't go through that. Real quick, I'm going to go back up here. Let me find it. I think, is it this one? R2, keep going. Because I think I need to fix the HSRP config in this right here. Let's see. Where are we at here? Here we are. It's one. Yeah. Let me change this to standby 2. Change this to standby 3. And then this will be standby 4. All right. So now we're going to go back down. And what I'm going to do now is just copy the config off the mop and just copy paste it into each device, and we'll see if the configuration works. Let's copy this one. All right, we go over here to R2. We go to the CLI. All right, and so we're now in privileged exec mode. I'm going to paste. All right, and we're going to see what we get here. Any incorrect configurations? It looks like we're all good for the router. Before we go off of it, I'm going to hit enter. That writes it and saves it to the startup config. We're going to go to show run, shows the running config, just to make sure that everything is like it's supposed to be. So we have console server, login local. We've got the VTY for SSH. That's right. We have our access list for our PAT, and that is right. It's letting right, that is correct. And then IP flow. All right, and IPNet inside source list 10 interface gigabit 001 overload. That is correct. And our OSPF commands, network, and then the default information originate command is there. That's great. Let's see. No IP. Let's see, where are we at? Here we go. 001 description, R2 to ISP. That's the correct ISP, or the correct IP right there. And same here. This is R2 distribution switch. That looks good as well. And interface loop back address, that's been configured in our spanning tree. This is not a switch, so we don't need that. LDP is enabled, and there's our security, our username and password. All right, looks like we're good on the router. This router can't really talk to anything yet because it's technically isolated until we get distribution switch up. So eventually I'll start pinging things, but for the time being, we're just going to leave that where it is. And bring my config back up here. Now we're going to do the distribution switch. Let's scroll all the way down to here. Copy that. We're going to go, not that one, this one. And CLI. Yeah, it's having some issues already. Oop. Boop. Paste. I always try to control C everything. Let's see. Do, 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 do. There we go. Oh, it took me all the way back to the bottom. I hate when it does that. Scroll all the way up. A lot of things got turned on, plus it keeps sending me to the bottom. So I'm going to give it a second. Where? I saw that in duplicate IP address. So let's see. Could be I forgot to change something, but let's look. 10.10. I think that was for the HSRP though. So I think we're fine there. I don't think it's actually going to be a duplicate address. Here, let's see. Show run. Let's see what we got. All right, and it's going to keep sending these. I'm actually, before we do that, so I don't have to keep getting those errors. It's doing that because I changed the native VLAN. And when you do that, but it switch to is screaming at me to also change its native VLAN or that there's a native VLAN mismatch. So I'm going to go ahead and past it. Go ahead and get switch to config or access switch to configured. That way I don't have to worry so much about that error. All right, let's take a look. 99. All right, we're looking good here. Since I'm already here, I'm going to hit enter, hit OK, and then we're going to look at the access layer switch first. Here we go. All right. So VTY, console. All right, so VLAN 99, switch remote access, that's on F06. F05 is IT, 4 is IT, 3 is admin, 2 goes to distribution switch 1, all those VLANs allowed, and we have F01 goes to switch 2 and has those VLANs allowed. All right, that's what we want. And we have spanning tree, RSTP enabled here, port fast default, again, as I explained earlier, extended system ID, and then we have LDP run and my username and security configurations. Enable secret, good. All right, everything looks good here. So I'm going to go over here now and check out distribution switch 2. So these commands should, or those errors should have stopped. And we've got OSPF loading done. All right, so we've got, those are right. IP classless, flow, and here's our OSPF, 4.4.4.4. Log adjacency change, networks are right, areas are right. All right, we got standby 4, 110, that's right, 110, that's right. So we've got G01 going to R2. Looks like I forgot to label that one. I'll go back and label it here in a minute. IP address 10.0.2.2, that's right. And we scroll up. All right, so that is right. That's the trunk. That's the other trunk. If I read this, that would be beneficial. Let's see. Then Ethernet 1, no switch port. This is part of the port channel. All right, a couple things I'm going to check here. Everything looks mostly good there. I'm going to first, actually, let me scroll up so I don't go to the wrong interface here. What do we have? Interface VLAN 20 G01. There we go. Okay, that's supposed to be to the router. So G01. So we're going to go into configuration mode, interface G01, and we're going to give it a description of switch 2 to R2. That should help now. And then the other thing I was going to do, we're going to exit out of config mode, and I believe the command is show interface port channel. Yeah. Incomplete command. Let's see, what do we got here? Oh, port channel 1. All right. Input errors. See, that would be part of the problem. Let's see, port channel 1 is up, line protocol is up. Okay, so we're actually good there. So that should have traffic flowing across it. Good. Okay. All right, so the next thing we're going to do, I'm going to check all these devices because if everything is configured correctly, they should be getting their IP addresses. Awesome. Well, it's got 10, no, no, not 2. It thinks it's in the management VLAN. Just need to swap that. And there we go. Now it's got the right IP address. This is, again, the IT network, and they're in VLAN 30, 192.168.30.12, 255.255.255.0 slash, that's a slash 24. So we have to go through all of these and allow them to get a new request for a DHCP. Boop, boop. And, oh, I have to go to the right section. Awesome. That got what it needed to. And it'll probably be all of them because since the DHCP path there wasn't actually configured. There we go. That one's right. Here we go. That one's right. 20.11. In a minute, when I say get all these, make sure they all have IP addresses, and we're going to ping and make sure everything is working. 10.12. I did set up excluded IP addresses within the DHCP pool, so all the pools actually start, the DHCP pools start at a .11. So whatever their first 3 octets are, the next octet will start at 11. It's good to reserve those first 10 for servers and other things of that nature, things you want static IPs for on that VLAN. All right, 10.15. All right, so we're going to keep that 10.15. We're going to go over here to IT. We're going to go over here to this guy. We're going to go here to the desktop and then here, and we're going to ping 192.168.10.13. And it usually will take a second the first time. So let's see. All right, the first one usually fails. The second one might even fail. It does have to go through a couple things, and let's hope the third one. Come on. Oh, that one failed too. Let's get the last one. Maybe. Okay, that one failed too. All right, so something's not working. Let's see what we can do about that. Let's see what we can ping from here. Let's make sure, let's see, ping 192.168. This is 30.1. Let's make sure we can ping. Yeah. Okay, that worked. Average, okay. Yeah, so we can ping there. Let's see if we can ping 10.1. Okay, it doesn't look like we can get over to 10.1. Oh, no, we did. Huh. Okay, so we can get to 10.1. Okay, 10.13. Let's do 10.12 just in case. Try a different PC. No, failed the first time. There we go. I may have gotten that .13 wrong. There might not actually be a .13. I thought this guy was .13. Oh, you're .15. Yeah, there's not a .13. So that's why it didn't work the first time. All right, let's see if we can go from, let's see, what are you? I want to see if we can go across. You are 20.11. All right, and this one is 20.14. So let's try to ping 20.11 real quick, just to be sure we can get that. Ping 192.168.20.11. All right, and that was pretty fast. Same VLAN. And now let's see if we can do 192.16. Oh, actually, I have to go to command 168.10. Let's do 15 this time. Make sure we can get over that guy. Pinging. There we go. All right, and it looks like we should be good as far as the devices are concerned. All right. So this was just a small enterprise network setup, and I enjoyed going over this topology and configuration. Thank you very much for your time.